In this lesson, we're looking at calculating surface area. So we're looking at 3D shapes and we're thinking about how much area would cover the outside of them. So a good analogy to think about is if I were to paint my shape, my 3D shape, how much paint would I need to cover all of that outside area, that surface area? The reason we're interested in this is things like, if you think about a satellite up in space, the only way to power it is with solar panels. So we want to know how much outside area our satellite has so that we know how many solar panels will be able to fit on it. A good way to do this is by looking at its net. An alternative way is by looking at the faces of the shape. So I'll show you what I mean in just a moment. So when we're talking about the outside surface areas of three-dimensional objects, if you add them all up, you'll have the total surface area. We're going to be talking about prisms and pyramids. They're both named normally after their base. So for example, if I have a triangle as my base and I put rectangles either side of another triangle at the top, I've got a triangular prism. So each of these sides are rectangular, the base and the top are triangles, so triangular based prism. For a pyramid, they all meet at a single point called an apex. So here's our triangular pyramid. So the bottom there is going to be a triangle, but everything else, well, actually we're getting more triangles when we make this pyramid, aren't we? Okay, so a good way to calculate total surface area is to think about the net of a shape. So for example, this rectangle, if I were to have a rectangle and be able to fold it out, say made out of paper, cut it up and then fold it out so it's one flat sheet, I can see that it is just a set of different shapes that'll have different areas that I can then calculate, add up, and get my final value. If we look at this pyramid, if I were to fold that out, I would get this net, looks a bit like a star, where it's got the square-based bottom bit and then 4 triangles that when you put them back together, you get the pyramid. So let me show you what I mean by how this is a good way to calculate surface area. So if I look at this square-based prism, what I can do is think about, all right, well, how many of each shape do I have in my net? If I just kind of draw in the bits that we can't see here. So I have my squares either side, right? They're both 6-sided, so 6, 6, 6, 6. So each side of the base, if I draw it out, you've got these squares and all the sides are the same. They're all 6. Likewise here. And then for this rectangular base, we see that it's got 12 centimeters as that side length, right? Now, if you think about how many of these rectangular sides would I need? If I were to fold this out, how many would I have? Well, I'd kind of cut it along, say, here. Well, I'd have that side, the far side at the top, the near side, and the base. So I'd have 4 in total, wouldn't I? So I can just draw them in. They're just going to be identical. Drawings don't have to be perfect. We're just doing it for the purpose of doing a calculation. So here, all these sides are 6, all the way along here as well, right? Otherwise, it wouldn't fit together. And all these sides are 12. So if I want my total surface area, TSA for total surface area, I can see, well, it's going to be 2 lots of this, the area of this square. So I'm just going to write it A, then a subscript of SQ. And all these rectangles are the same, right? And I have 4 of them. So I could do 4 times the area of the rectangle, REC. Now I think about a square. The area formula for that is length squared. For a rectangle, it's length times width, LW. So then I sub in my values. So for my square, all my side lengths are 6. So I'm doing 2 times 6 squared plus 4 times length times width. So we could say the length is 6 and the width is 12. So if I do all of these calculations, what am I going to get? Well, 2 times 36, I reckon that's 72. And then here we've got 6 times 12 is also 72 times 4. And it's kind of getting to the point where my mental maths is not enough for me. So I'm just going to look at my answer here. So it's 72 plus 92, ultimately 264 centimeters squared. So we notice we're still using centimeters squared, even though it's a 3D shape. We've folded it out to be a net where it's a 2D shape. We've turned a 3D shape into a 2D shape, so we know the total surface area. Very good. So for this kind of thing, I would probably use a calculator that, we're starting to deal with numbers big enough that worth using a calculator. All right, let's have a look at our next one. we want the total surface area of this rectangular based pyramid. Again, what I'm going to do is I'm going to draw this net. So I'm going to draw it up here. What you do is draw, if you notice, those rectangular sides are different. So we'll say, here's our rectangle. I'm not sure I've given myself enough room here, but this is 10, this is 6, and we know that this side is the same as that side, this side is the same as that side. Yeah? And now if I look at, say, this face, if I were to fold this out, fold out its net, that face, the one nearest us, would come down here, wouldn't it? We told it's got a vertical height of, it would appear 12 centimeters. So I'm just going to draw that in as a dotted line, 12 centimeters. And the base is also our 10 here, isn't it? 10 centimeters, 10 centimeters. For, say, this side length, right? If you were to fold that out, it would come out here, wouldn't it? So I'm not really giving myself enough shape, enough space maybe, but something like that, right? Just a sketch. This is 8 centimeters, and this is still 6 on the bottom, yeah? And then if I just scroll up a bit, the opposite side, it's got to be all the same, right? If it's going to make a pyramid. So this bit, this is going to be 12. And this one, smaller bit again. So down to 8. Cool. My drawing's a bit exaggerated at parts, but that's okay. What we'll do is get our total surface area. So if we want the total surface area, what we can do is kind of look at our shape. So we've got the area of that rectangle on the bottom. So I might just do it A and subscript R plus 2 of these small triangles. Yeah, they're the same. So we might as well just do 2 times ST for small triangle. And then we've got the large triangles on the other sides. So 2 times area of LT, large triangle. So the rectangle is length times width. The area of a triangle is base times height over 2, half of the base times the height, right? Likewise with this triangle, they're just going to have different bases and heights. Now you might notice, if you're good with your fractions, that there's a 2 on the top there. We're timesing by 2 something that we're halving later. If you think about it, if you times something by 2 and then half it, you may as well have not done those things, right? So they cancel out, don't they? So what we'll do is we could just do a bit of simplifying and do, well, it's just going to be length times width, where, so we've got 10 and 6 from our diagram. For our rectangle, we're going to have 10 times 6 plus, so this 2 will cancel out with that 2 on it. So we're just doing base times height in the end because we got 2 of them. So 10 times 12 for the large triangle. And this one, the small triangle, 8 times 6, the base and the height, right? Vertical height. And I think I've made a little mistake in terms of I did small triangle here, large triangle here. Doesn't really matter. We're all adding it all up together, and that, so in the end, the order isn't going to matter, but let's do it. So 60 plus 120 plus 8 times 6. What is that? A bit late in the day for me today, so my brain isn't working at full capacity. I reckon 8 times 6, I know 7 times 6 is 56, so it must be 48. Yeah, that's right. And then we can add all that together, so we've really got 180 plus 48, so because those will make 180, so it'll be 228. And we're dealing with meters, so meters squared. Here we go. Cool, very good. All right. Here's a little challenge for if you are up to it. Have a think about that one if you get a chance, but thanks for watching.